Okay, it's 4.5.1, and this is about graphing. We're getting ready for a graphing test. So you're going to be learning a couple more kinds of graphs, and then we've already learned a ton about graphing. You've already learned like what period means and amplitude means and all that stuff. So I want to start by doing one you already know, sine. Would you just remind me how to graph sine of x? Just plain and simple, graph me sine. Label the 4 important spots on the x-axis. Label the 2 important spots on the y-axis. Just make me a nice graph of sine. Because today's is about cosecant and secant graphs. And they are totally dependent on sine and cosine, because remember how they're sister functions? If they're really sister functions, then they're flippant sisters. I described them that way. They're reciprocals of each other. So the one is 1 over the other one. So as one of them gets really big, the other one will get really small because it's the reciprocal of it. You get how, like, if I get to be bigger and bigger, and it makes 5, 10, 15, then 1 over that gets really, really small. 1 over 5, 1 over 10, 1 over 15 is really small. So the point is, as the one gets really big, the other gets really small. So to understand cosecant, you'd really have to understand sine first. So let's graph sine. If you haven't already, it should look something like that. And it goes up to 1 and down to -1. And it has these 4 important spots, there, 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 and there. And this is 2 pi, and this is half of that, which is pi, and this is half of that, which is pi over 2. And then I like to count it back up to make sure I did it right. This is 1 pi over 2. That would make 2 pi over 2. This part to here would make 3 pi over 2. Okay, did you all label that correctly? That's the graph for sine. And a couple things we knew about it. Its period was 2 pi. Its amplitude, which was this distance, half of the total, just from here to here is the amplitude. Okay, the amplitude is 1. And it hasn't been shifted at all, so there's no phase shift, etc. All right, I'm going to clean mine back up again and make it back to just those, and I'm going to make this 3 pi over 2. A nice clean graph. Here is what cosecant looks like. You can put it on the same graph. As this is 0, if this is the flip of sine, then it's 1 over 0, which is undefined. Wherever sine is 0, its sister function is 1 over 0, which means undefined, right? So everybody put dots at these 3 places and then put an asymptote line because it doesn't work there. Cosecant can't exist when sine is 0. All right, now cosecant is going to ride on the back of sine. And big picture, it looks kind of like this. And on the other side, now this is an important concept. Sine and its sister, which is the green one I just graphed, cosecant, they both have a period of 2 pi. And I get how you might be confused by that and think, wait a minute, isn't this a complete cycle right here? Nope, it's not a complete cycle because it didn't include any of the down action, which was that part. It needs both of those to be a full cycle. So its period is also 2 pi. Okay, so now, do I really need the sine graph in there? Nope, that was there just to kind of help me make sure I put cosecant in the right spot. There, now I got cosecant. Now I should go back and number those important spots. They're still the same. This is 2 pi. Now this is pi over 2. This was pi. There we go. There's the 4 important spots. Oh, and then there's this spot, which is 1, and this spot, which is -1. There's cosecant. Go ahead. I'm recording right now, so I'm going to pause for a second. If that's cosecant, let's answer some questions that we'd had to answer before about sine. What's its period? I just said it 2 seconds ago. 2 pi. What's its amplitude? There is no such thing as an amplitude on this thing, in that just think about it. The amplitude is like how high the wave goes. This doesn't have anything like that. If we're going to measure it from infinity up here all the way down to there, that's not going to make any sense. Okay, so you can't do amplitudes for cosecant. How about domain and range? How about domain? Domain goes this way, right? Does everything work forever in both directions? No. We told you already about 3 spots that don't work. Those places where we made the blue asymptote lines. So is the domain on this from negative infinity to infinity? Nope. There's a million, in fact, infinite number of spots that don't work. So if I asked you for the domain just between 0 and 2 pi, you would say it works between 0 and pi, and it works between pi and 2 pi. You get how the domain here? Hi there. All right, so sorry to a little interruption there, but we were talking about the domain of cosecant. So it works in here and it works in here. The main thing that's important is that it doesn't work where these blue dotted lines are. These are asymptotes. Why doesn't it work there? Because cosecant is really the same as 1 over sine. And if sine becomes 0, it becomes 1 over 0. And that's why it doesn't work there. Okay. So, take a wild guess how you make secant. By first making what? Cosine. Everybody make me a nice cosine graph so that we can eventually make secant. Make me a nice cosine graph. I always like to start my numbering at the end, 2 pi, and then I go halfway, there's pi, and then I go half of that, pi over 2, and then in between here, 3 pi over 2. I never feel like I draw cosine perfect, but that's okay, you don't have to be perfect. There's 1, and this will be -1. Okay, there's my cosine graph. So same deal, whenever cosine hits 0, what does its sister function do? If cosine is 0, what's 1 over cosine? It's 1 over 0 and therefore undefined. So at these spots here and here where cosine is 0, then its sister function, which is known as secant, if cosine becomes 0, secant, which is 1 over cosine, and cosine is 1 over secant, becomes 1 over 0. So it can't exist right here or here. Now this one is not quite as clean to draw. It is down here. This part's easy. Just rides on the back, just like before. But to get the rest of it, you have to get the bigger picture of where this is going. So I'm going to let my cosine graph continue a little further, etc. And then where it hits over there will be another asymptote. And then I can make the rest of it and see, oh, it's just going to be a loop on top of that. But notice, I'm not going to keep going. And then this one would be riding on the top here. But again, if I had extended this out further, saw where those two crossed and said, okay, there's an asymptote line right there. And then it must, but do you see the red graph and how it has kind of incomplete cycles? In other words, I don't want to complete this. I don't want to make this like this because now I got a period and a half of it. I need to have 1 period of it, so I need to have one down cycle, see like this, and one full up cycle, which ends up being 2 half cycles. This and that. That is cosine between 0 and 2 pi. It's just the same thing as the other one. It just rides on the back of its sister function. It's just, if I were to complete this, now I got too much. I got 1.5 up cycles and 1 down cycle, and that's more than 1 period of it. Now, one thing I could do, if you want to, and when you're asked to graph this, you could not graph that part of it and just graph 1 full down cycle and 1 full up cycle. So in other words, right here, 1 down cycle and 1 full up cycle. Now that's also 1 period of cosine. How long does it take to complete? It takes 2 pi like before. But if you go from pi over 2 to this spot, which is, let me see, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, this must be 5 pi over 2. If I go from pi over 2 to 5 pi over 2, when you subtract those, you can still see that minus that. It still gives me 2 pi for a period. All right, so if I was going to make a quick sketch of cosine, I'd start with, a quick sketch of secant. I would make a quick sketch of cosine first. And then I would say, okay, wherever it's 0, its sister function would end up being 1 over 0. So it can't be here, and it can't be there. And then I'd make this, I'll make it in blue. This is the actual graph of secant. There we go. There's secant, the blue part. The red part was just there to help me. And then do you have to label it? Yeah, you still have to label it with the 4 important spots. So, of course, this spot, if you just keep it simple and those go from 0 to 2 pi, that's 2 pi. Here's pi over 2, and here's 3 pi over 2. And then how high is this? 1. How high is that? -1. There we go. Now, of course, it gets more complicated. This is just day 1 of cosecant and secant. And you can imagine pretty easily, if I wanted to change this to have a stretch factor, y equals, instead of just secant of x, what if I wanted to make it 3 secant of x? Then it would take a wild guess what I do. Yes? Perfect. Yep, 3 and -3 now. Okay? And what if I wanted to make this not be secant of x? What if it was secant of 3x? No, let's not use a 3 again. Let's use 2x. Then these have the same exact formula for their period. The period is always starts at 2 pi. Divide by b. What's b in this case? 2. 2 pi divided by 2. So if I divide that by 2, instead I would rather multiply by 1/2. I will multiply everything by 1/2. By 1/2. Remember doing this before? It's the same exact process. Okay, so this shouldn't really, I mean, all you have to do for all today's problems would be to do it as if you were graphing sine or cosine. And then when you're all done, you just got to throw in a couple asymptotes and make the thing ride on its sister's back. So if it was like this in the first place, that's cosine, right? You just have to put in these asymptotes here, and then the blue lines where it's riding on its sister's back. So really, it's kind of an easy day, because it's pretty much just what you did before, except you got to know where to put in some asymptote lines and make the function ride on the other function's back. All right, so let's see if you really understood that. Only know when you actually do a problem. So I want you to try this one on, make yourself a new graph. Nice, start with a nice clean one. And I'd like you to do cosecant. That's the one that rides on the back of sine. And I'd like you to do 4 CSC. Let's just do 4 cosecant to start with. And in a moment, I'm going to have you compare with somebody. I'm going to pause for a second and pair you with two people that you normally are not paired with. Okay, so here's how this went. Start with you do sine. I'll do a really quick sine. 2 pi, pi over 2, and 3 pi over 2. Okay, now I got to number this from, instead of 1 and 4, or 1 and negative 1, I'm going to do 4 and negative 4. Why did I do that? Because of that. Okay? That stretches it up, down. Now I just got to figure out, it rides on the back, right? So you can start with these if you want to. But if you don't have the asymptotes in there, I will not be able to give you the full credit. The asymptotes, whenever sine is 0, which is like there, there, and there, then 1 over 0 is what the other function is, and therefore it does not work. Therefore you need asymptotes. There we go. Raise your hand if you had that one right. Okay, good. Now I'm going to make one little tweak to the problem to make it more like a test question. What if we said pi over, no, x over 2. Yes, we'll have to renumber now. So see if you can figure that out. I'm going to pause while you do that. I was asked the question, should we have erased the sign in there? Yes. I'm not sure how much percent I would mark off, but if you had the sign graph left in your answer, you know, this part that I'll draw in green, you would lose some partial credit. So thank you for noticing that. I should have removed that to get the full credit for this. Okay, so back to your renumbering now based on this little guy, and hopefully you remember the formula for period because it'll tell you what to do. I'll pause while you try that. Okay, you should have started with 2 pi over b, and 2 pi over b, b is 1/2. But would you really want to divide all of these by 1/2? No, you'd probably want to change that to multiply everything by 2. So you should have timed everything by 2. Times 2, times 2, and times 2. And the 2 on the top and the bottom cancel, that becomes pi. That becomes 2 pi. That becomes 3 pi after the 2's cancel, and that's 4 pi. 1 pi, 2 pi, 3 pi, 4 pi. That make sense? Okay. That's it. You learned everything you need to know. Now let's start your homework together. It's 4.5.1. Let's see if I can get it up on the screen here. Okay, so I think we're ready to start 4.5.1. And this is asking you to graph cosecant. We just did it. I would like you to transfer that if you have it in your notes. Maybe you can do it in your head just as easy, but over to this worksheet. I would make every 2 marks be the important spots, personally. And I'd make my sign go up 2 marks and down 2 marks. But you can do it however you want to for your numbering. That's pi, this is pi over 2, and this is 3 pi over 2. And then sine is where I'd start because cosecant, which is CSC, rides on the back of its sister function. So here's sine, and then it rides on the back, there, and there. And it doesn't look like they've asked me to stretch it or anything, and that's cool. That makes it easy. What have I forgot that I would, there's 2 little things I've forgotten that I should do before I finish. Yes? Label the y-axis. Actually, you're right, although if you hadn't labeled it, I have told my kids that they default to 1s. But then take out the middle graph. This should go. You're right. One more thing. Asymptotes. It has to have the asymptotes in there. So asymptotes here. And you can just kind of look and see where they should go. But if you leave sign in there when you make the asymptotes, it's kind of easier. Because then you can just see wherever sign's touching 0, then its sister would be 1 over 0, and therefore it doesn't work. There we go. Now, with that out of there, I have correctly graphed cosecant. Okay? For what values of x does cosecant of x equal 1? Sounds complicated, but it's just asking, when in this whole graph is the function, which is the green one, equal to 1? I see it right there. Boom. That's a place where it's equal to 1. What is that? Pi over 2, That's a value of x, right? These are all x values in my chart, all of these. Okay. For what values of x the sine of x equals 0? Oh, they're kind of talking about those important spots, the asymptote spots, right? So where was sine equal to 0? I can put it back in. You can do this too on yours. Just drag it back in and go, where was it touching? Oh yeah, it was touching at 0. And touched again at pi. And touched again at 2 pi. What is the y-intercept? Well, if I look at this graph, where is it? Now the y-intercept of, not sine, but the y-intercept of cosecant. I should have really said that. What is the y-intercept of cosecant? It doesn't touch, does it? Does it ever touch the y? Isn't there an asymptote like right on that? So it'll never touch it, right? So you'd say none. Part C, for what values of x does cosecant equal -1? Oh, that's pretty easy. Remember, this is the y. The y is -1 of the graph, and that's right there. So you follow it up, and it should be easy. And then, where does it have vertical asymptotes? Oh, it's the same thing as where sine is equal to 0. You know what I mean? That's what I was telling you. That's why they have asymptotes there, is because sine is 0, and so when you have cosecant, you have 1 over sine, and therefore 1 over 0. So the same exact places as where sine equals 0. Okay. Now I'm going to go down here to number 2. Definitely need you to do this one because it's the base. Secant, rides on top of cosine. And then there's a couple where we got to do some stretches and stuff. I'm going to cut this down a little bit because this assignment's a little bit longish. I'm going to let you skip number 3 and number 5 and number 7 and number 9. 3, 5, 7, and 9 would be very reasonable. And 15 and 16. 3, 5, 7, 9, 15, and 16. If you understand all the other ones, that'll be enough. Now my deal is, I really do expect you to get your homework done every day, especially when I'm cutting a bunches of it out like that. Then that makes it very reasonable to expect you to have this puppy done tomorrow. Okay, and don't forget to check. There's answers posted for some of these. And that's all I got for you for today.